All right, so we're going to be taking a look now at deductive reasoning, and I just want to quickly go over one little thing from the last lesson on counterexamples. So here we have what we call a counterexample. Okay, we were given an example that we were told to find, we were given a logic proof about something that was, a conjecture that had happened, and then we found some examples of people who went against that conjecture, and we found things that didn't actually work, and so that is, it's a counterexample. It goes against there. And if we just take a look at that, I had one more thing I forgot to get through in the last lesson there, but if an example uses a false premise, okay, and so this we can think of as like a hypothesis, okay, or an idea, a false kind of starting idea, then there's no rule again. If it uses a false premise, okay, it just doesn't work. Okay, as there's no rule, it just does not work. So that's just a little bit of kind of refresh from last class when we talked about counterexamples, and we're going to go through some counterexamples today as well. Now, deductive reasoning is a little bit different. Inductive is all about making, coming up with a pattern and having some sort of conjecture that goes with that pattern. Deductive involves proving a specific conclusion based on generally accepted facts, or general accepted, I should spell that right even on the videos here, accepted facts. Okay, so it's making sure that we know something based on general accepted facts, things that we would believe are true. Okay, so something like gravity, it's generally accepted, okay, and it's generally known, the scientific community says that gravity works to keep us on this earth. Okay, and we have kind of an idea of how well it works. That is deductive reasoning based on what we know as general facts. Another way to say that would be proving a fact based on other true facts, or coming up with a conjecture, okay, conclusion, based on other known facts. Okay, this can be proved using math, research, or laws that have already been set in place that are part of our daily lives, the scientific community, and so on and so forth. So let's take a look at an example. Okay, and I'm going to break these videos up into different examples. I'll probably do one or two examples per video. So example number 6 here is that humans are mammals. Okay, this we know by definition. That's a generally known fact. That's the definition that biology has, is that humans are mammals. Okay. We also know, again, by definition, that mammals are vertebrates. Okay, meaning that we have a backbone. Okay, so we have a backbone that's inside of us. Okay, not outside. Mammals are vertebrates. Okay, by definition, that's a generally known fact. So if we know that Bill is a human, okay, this is some sort of specific reference. Okay, maybe you have an Uncle Bill. I do. Okay, so if we say that Bill is a human, okay, what can we say about Bill? Well, based on what we know here, all humans are mammals. So we can say that Bill is a mammal. Okay? And this is by definition. Okay? It's by definition. It's what we know right here. Okay? So based on that, we know that Bill is a mammal. Okay? And if Bill is a mammal, we can take it one step further. So we know that mammals are vertebrates, so we know that Bill must be a vertebrate. Okay? And this is by the deductive property. Okay? So based on what we know that Bill is a mammal. Okay? And so from that, we can say that he's also a vertebrate. Okay? We're not told that Bill's a vertebrate. Okay? We're not told that humans are vertebrates, but based on the path that we see, humans are mammals, mammals are vertebrates, it follows along that path that Bill, being a human, will also be a vertebrate.